Welcome everyone. Thank you for joining me today as we explore the topic of how to get more people on board with Pharo. My name is Pascal Zaragoza, and I'm here to share with you our proof of concept that can help us expand the small talk community. As many of you know, Pharo is a powerful and dynamic environment that fosters productivity and creativity. However, like many specialized tools, it faces a challenge in attracting and retaining new developers. The steep learning curve and unique aspect of Pharo can be daunting for newcomers. To address this, we wanted to leverage the potential of large language models to support the onboarding process. These advanced AI models can provide personalized guidance, answer questions in real time, and offer practical examples to ease the transition for new developers. Today, we will delve into how LMs can be integrated into the onboarding workflow to see the benefit they bring, and maybe a couple of real-world applications that demonstrate their effectiveness. Before I begin, I want to say this is a large part of the work of our intern, Marius Pingo. Unfortunately, he couldn't be here today since this is exam week at his university, so I'll be presenting most of his work. So to get started, I wanted to talk about the typical new user experience when you're learning a programming language. And for me, what I like to call is, how do I do this? Which as a user is you get into a new environment, a new programming language, and you know the basic algorithms and object-oriented stuff, but you don't know how to do something in a particular language. So you'll have, for example, a collection, order collection. You say, okay, now I have a collection. I want to order it or sort it. So you'll try typing in collection order by, or shift enter. You'll try to find a method, but maybe you won't find it. So this is when you ask yourself, how do I do this in Pharo Smalltalk? So typically the user has an option. He can try using the documentation. So at first, he can go online, look at the resources. We have several resources online. A lot of the community provides a lot of documentation, books on how to use Pharo, how to use Smalltalk, and in general, just object-oriented programming. So this is pretty useful. It's highly complete information. It allows the user to learn a lot about how everything works, but it's highly dependent on the user's expertise in learning new programming language, and also dependent on the documentation availability or easiness to use. The other way new users experience or learn to use a programming language is they ask experts. So they'll ask, how do I do this in Pharo with Smalltalk? So they'll go on a forum like Stack Overflow, or maybe go to on Discord or Slack. They'll ask a question, and so they'll wait. And then eventually an expert, when they have time, they'll come in, they'll read the question, try to find the error or debug the code they put in the forum, and then they'll give a thoughtful and complete answer, hopefully. And their user can then read it, and that's great. Usually it's a rich and interactive response. However, it can be a slow process. Interesting today, or at least the last couple of years, is large language models, which offer the ability for users to talk with a chatbot and have a near instantaneous response. So in this case, the user will connect to a website like ChatGPT. Now there are multiple ones. They'll ask their question, and then the black box, which is the LLM, will churn out an answer, and that answer is up for the user to use. Now, typically, for example, the example that I'm using, what are the main methods used to sort a collection in Pharo, and how do they differ? And the LLM will say, oh, in Pharo Smalltalk, the main methods are used to sort a collection are sort with a parameter and a particular custom block, and a sort ascending method. So, okay, the user comes back to his code. It's like, okay, now I'm going to use sort. Okay, cool. It ordered my collection from the smallest to biggest. Now I want to try the sort with a custom comparison block. And okay, great, I sorted it from descending order. And finally, he's going to say, okay, let me try sort ascending. And there he's going to see, okay, that doesn't work. And so he'll say, what happened? And just as a example, this is a real example. When I typed it in ChatGPT at one point, it actually gave me this answer. So it's even with a very popular LLM, it's still possible to get highly wrong answers. So and indeed, if we check the implementation for the collections and sequential, you can see that there are methods for sort and sorted, which are intended to be used. So this is what I like to call the number one problem with LMs, is that they have limited knowledge with a cutoff date for learning. So when they train those big foundational models, they'll decide a cutoff date to collect all their data, and then they start training their models, and then they release it to the public, and that's it. Any new information, any new updates to your programming language or your implementations, it won't be taken into account. The second problem we face is, so in this example is, a user is using a specific library or an internal program within your company or within your community, and so they ask the question, how do I do this in my library? And of course, the LLM, which shouldn't have access to internal data or internal code, is going to say, I'm sorry, I don't know anything about that. And for me, that's the second problem, which is similar to the first one, but a little bit more precise, is that the LLM doesn't necessarily, or will never have access to your internal business rules, and so they are known to foundational LLMs. So for these two problems, the community offers at least two possible options. The first is quite classic in the AI community, is to fine-tune your model. This has obvious advantages and disadvantages. The first being disadvantage is it can be expensive and difficult. And the end result, as we've seen with the example of collections, is that it can still cause hallucinations, where the answer is slightly wrong or can lead to wrong answers. And the other solution that's been pretty popular with the community is to use what we call retrieval augmented generation, which is the principle of, if you have a question and you have documentation, then maybe you can provide the relevant documentation with the question to provide a customized response. I'm going to show you a quick example to show you what I mean. Is, if you went on ChatGPT and you asked it, what is Tom's age? The ChatGPT would just say, I don't know what the age of I don't know the age, I don't have enough information, can you give me more context? However, if you said Jack is 24 years old and Tom is 3 years younger, how old is Tom? And then, of course, it's able to deduce that Tom is probably 21 years old. So this is what I mean by a retrieval augmented generation, is if you provide the right context, it can increase the quality of the response. Of course, so the advantage of this technique is that all you need potentially is just the right documentation. However, the disadvantage is that you need to provide more data with your initial query, which increase the inference costs. So for this tool demo presentation, we decided to go with the second option because it's a less expensive, less difficult process to implement this solution. So I'm going to present you into more detail the typical retrieval augmented generation, or RAG technique. So you have the same user interface. So when the user asks the question, however, this time, instead of sending it straight to the LLM, it'll be intercepted by a backend, which will try to retrieve the most relevant documents based on the question. So it'll do this by a semantic analysis. So more particularly, we'll use a vectorial database with documentation, and we'll calculate a semantic vector for the question, and try to get the closest semantic vectors in the documentation. And this way, we'll be able to get the most semantically close documentation. And then this question and the documents that were retrieved will be sent to the LLM, and the LLM can attempt to answer the question. And then, of course, we'll format the answer and send it back to the user. So when I talk about retrieval augmented generation, we definitely see this retrieval part where we get the right information for your question, and then, of course, the generation part where we still contact an LLM to generate an answer or a text. Now, a question you might ask yourself is, how do we actually build this database? Well, what we do is we collect a lot of Pharo documentation. So, Pharo Wiki, Pharo by example, raw cell documentation, whatever PDF, Markdown, or HTML page we want to collect. We open, clean, and parse each document. So we extract the data as a readable text. So it has to be readable for a user. In general, to be readable by a classic LLM. And then due to size constraints, when we pass a document or a text to an LLM, we have a maximum length for the documents. So we have to segment them into tiny little bits for segments. And then we can use an embedding model to extract a semantic vector, which will represent the segment in question. And so then we can associate this vector with a segment of the documentation, and eventually any metadata we want to keep about the documents into our database. So I'm going to move to the tooling and evaluation part. So for the tooling, we set out to create initial tooling in Python. The reason we stay with Python is that, or at least for initial tooling, is that a lot of the AI community does a lot of packaging or packages or implementations, which allowed us to quickly iterate over this process. And for the data collection, we identified and processed a set of Pharo documentation. We decided to keep it a low count to test the viability of this. So we limited ourselves to Pharo Wiki from Pharo Open documentation, a couple documentation from Square Bracket Associates, so Pharo by example 9, and learning object-oriented with Pharo. And we also added 2 library documentation, so application with Spec 2 and ROCL documentation. Now I'm going to move to the demo part. Let me see. Let's see if we can actually see it. Yeah. Oh, sorry. So here's for the demo. To actually ask the question, you first have to select the type of documents you want to check out. So currently we're limited to either searching within all of our documents, the Pharo documentation, the spec documentation, or result documentation. We also added very recently the code aspect of Pharo. This morning I was checking out the demo. The ROCL is buggy, so we're just going to keep to Pharo. I mean, buggy from the documentation side. No, I mean from my part, not their documentation, of course. So I'm going to have to put this down for a second. I don't know if you can hear me. Yeah, okay, perfect. So Pharo, if we ask the same question we asked before, so how can I sort a collection in Pharo? So this question is sent to our backend. It should retrieve 4 different questions, 4 different documents, and then generate a response with, we use GPT 3.5 Turbo. So here we have our answer, and it looks to be about correct. We have the sort and sorted methods, and if we check out the documentation, which is, I think, the ideal thing when you're working with a RAG augmented LLM, is that you can actually make sure that the documentation actually has information. So here indeed we can see that it mentions 2 main methods, sort and sorted. And you can see here you even had a couple examples. No, this time I didn't decide to show these examples, but you have more information there. Also, let me see, I have another question for, I think, spec. What was my question? There we go. So typical, what does SP presenter class do? And then, of course, if you check out the class here, I just have to talk a little bit louder. Hope easier. Nope. You can see indeed. Here once again you can find the documentation part where it explains what SP presenter does, and you can see it repeats it here. So it's a nice little tool for getting a quick feedback on the documentation. One last question I want to try is, I think I have it in Pharo. So I just took, yesterday I was playing with it. 1 second. Yep. So what you may not see here is that I went on Pharo and just grabbed a random class that exists in Pharo 12. And I decided to search based on the Pharo code. There you go. See. So we'll see. bit hard to see. So it's Athens Caro pattern paint. And usually, no, okay. I probably have this class. So yeah, you can see here it was able to output the right document. So then we have to see if the text is actually interesting. But GoSnippet represents the mesh gradient of the Caro backend and includes methods to create a mesh gradient with patches. So if anybody's particular informed with this class, maybe they can pitch in and see if it's actually correct. But that's about it. I'm going to go back to the presentation. Let's see. There you go. Now that I talked about the demo, I'm going to go back to the evaluation. So we actually wanted to see if it was actually useful as a tool. So what we did is we generated a set of textbook questions, 21 questions in particular, and we extracted a set of questions from Discord and Stack Overflow. And we decided to run it through the naive LLM, so GPT 3.5 Turbo, as well as running it through our pipeline of RAG. And then we decided to evaluate each answer for each question on a scale of 0 to 3, 0 being terrible, 3 being perfect. And we were able to compare those results. And for the initial results, we have, for the textbook questions, we can see with the RAG technique giving near perfect answers, where, as you can see maybe on the right here, we have the naive LLM, so without the documentation, we can see it performs on a broad range of 0 to 3 in score, except when we use the RAG technique, it's able to increase itself to either an OK or perfect score. And then for the second part, for the Stack Overflow questions, so like we said, we selected 19 questions from there. So we can see the initial results are much closer. But I think there's still a small shift towards answer quality. So when I compared individually each question, there was a tendency to have a question that was normally scored 0 in a naive technique was upgraded to a 1 when it was the RAG, and there was a tendency to shift towards the right. However, I think we see there's a lot less of increase in quality. So that's why I'm going to move to the conclusion about, so like we said, the textbook-based results are extremely positive. However, once we try the Stack Overflow-based results, we show there's a lack of significant impact for the RAG-based onboarding LLM. So the next question for me, which was pretty logical, was why, what happened? So when we look at the answers individually, what we did notice was when the RAG-based technique had a better score, it was usually because the document provided within the questions did contain an element of the answer. Inversely, when the RAG-based technique was not better, the documents provided were not related, or did not contain any elements of the answers required. So this leads, so for example, in this case, for the RAG technique, which gave a better answer for this question, which is the usage of dot in Smalltalk, the RAG-based technique had a more complete answer with an example, while the naive technique contained a simple explanation with some ambiguity. And indeed, when we checked out the documentation, we did find a documentation explaining the rules around it and actually giving an example. So what could this mean? I think it's for the initial results is one, we did not have enough documentation to answer some of these questions, especially when we checked out some of the questions that we extracted. We also checked out the documentation. It was kind of hard to find an answer. For example, for the example of the first question, which was when a path is not specified, where are the files saved by default in Pharo? The documents we checked out didn't particularly explain, of course, where the documents were stored in Ubuntu or Windows or MacBook or Mac OS. Sorry. And for the other example, how to use computer mics as a sound input in Pharo, the only documents that mention how to use the mic input were actually extracted or retrieved during the RAG process, but it did not actually have any elements of the answer to actually completely answer this question. So the next part is sometimes the questions are maybe a little bit too complex to answer with a simple request. So for the perspective after this initial tooling, what we want to do with this is, I think, just increase the amount of documentation. We're open to getting any type of documentation you guys have to see, run it through our pipeline and see what happens. Also, we also want to include, I think, other data sources. I think this is the actually really interesting part is currently we're just doing, for me, what I would consider a naive approach, which is just to stuff a database with lots of documents and hope for the best. I think including other data sources such as Moose models or directly the Pharo code and slightly tweaking the way the retrieval process works could give us a better results concerning some of the questions we have. We could imagine having the Moose model behind a specialized API, which will allow basically any analyzed project, Java project, to be queried through natural language to get specific answers. For example, what other classes are most dependent? Maybe high level questions that are object oriented, but maybe it wouldn't be possible through parsing textual information, but having an organized information for a graph, for example, a Moose model, it could be a very interesting venue. So it would allow us to ask questions about specific code bases, for example, like I said, what superclasses is about. And then also, I think it would be interesting to go towards a more agent-based programming to iterate over more complex questions. Currently, the algorithm is rather simple. It gets the top 4 documents that are semantically similar, and then it gives it to the LLM and gives the question and attempts to answer. I think it's a good initial, it's a nice start, but I think it'd be more interesting to have the LLM have the ability to iterate over the questions and it answer the prods. So for example, if we retrieve 4 documents and they do not answer the question, maybe have the LLM say, hey, I want more documents, and then provide more documents and have basically a feedback loop until we get the right information, or maybe ask the user directly, hey, I don't have any information about this. Can you give me more precise information? And so I think adding just agent-based programming, it should be interesting venue for this. And finally, we've also started using this tool internally within our company. Since we have a couple of new users within the research team that have been using Pharo, we've also given them access to this tool so they can start asking questions. And so we want to collect, we started collecting their questions and answers, and so we can also evaluate on real user questions. So I think I've talked about everything I wanted. I think it'd be fun for you guys to try it. I made it available on the website over here. I have the QR code. If you have any questions, you can don't be afraid to ask them. If the server goes down during the week, be sure to tell me so I can bring it back up. So yeah, thank you for your attention.
Based on your experience, does the RAG usage reduces the hallucination phenomenon?
Yeah, you can hear me. Okay, perfect. Yeah, and for me, yeah, we're also using it internally in the company. We started deploying it for support, client support. So we've definitely seen a net decrease when we use the RAG. Yeah. Right. I think it reinforces when you give it a text, it reinforces what it probably knows. It reinforces it, and then yeah.
All right. And the other question is, and in the case of code, how do you plan to feed the RAG? Because the code is something that changes constantly. So how do you plan to do that?
Good question. We had, yeah, maybe it'll be easier for this, so everyone can hear me. We had 2 main ideas. The first one is going through a CI/CD pipeline. So every night, for example, in the case of developers, we also wanted to apply this to developers with our own internal code, so in Java and other. What we want to do is have a pipeline where we analyze the code base every night or every couple of days. I think this is a decent way to do it, at least initially, because I don't think the code changes too much in between, at least in between days. However, we also thought about doing this locally. So a RAG system, the good thing about it is that it's not too intensive on the user side. It's only, you can have an in-memory database for any of the code that's been changed. And I think that's the sweet spot of having any local changes taken into account, while also having all the data, all the source, data, code source, being done every night, for example.
Great, thanks.
Thank you. Whenever I've used Stack Overflow or something like that, one of the most valuable feedbacks for me is this technique is a deprecated technique. It's an old technique that we don't use anymore. Here's the technique that you want to use. That's the better technique. Is there any way for a large language model to distinguish between an old technique that's really not used anymore and a new technique that's better and improved?
That's a very good. That's a very good question. I think you have the same thing. We're going to have the same problems that I highlighted in the beginning. Is that maybe eventually it'll be trained correctly to have the latest technique or the latest implementation of your package. But as soon as you start changing it for a better technique or a better use case or best practice at least, you're going to encounter the same problems again. I think this is why keeping the same type of RAG-oriented augmentation of feeding it best practices alongside maybe information about your code or the code base or the package you want to use to also tell the LMO, by the way, here's the best practice, and it may guide it towards a better answer.
So first I would like to add to the previous question about the hallucinations. You said that we could reduce hallucinations using RAG, but can we completely avoid hallucinations in some cases? For example, if we have a database and we are certain about specific things in that database, we are certain about certain classes, certain code, can we fix it in the LLM and force it to only answer the exact facts from the database?
I think LLMs are always, I mean, I don't want to say always, but I think they're predestined to have some form of hallucination. I think it's just how, since it's a probabilistic model, you can choose the wrong word and go into like the wrong direction. I think there's always going to be some of that. I am a proponent of having checks on the back end. So before and afterwards, before you can increase the quality of the input text, and afterwards you're going to have to control the output. So if you have a code output, you can always test it, give it a feedback loop where, oh, their test is not passing the initial testing, and then maybe improve it there. Otherwise, yeah, I think hallucinations are always, in my opinion, always going to be always be there. Yeah.
Thank you. And my second question is about documentation and the support for custom libraries. So how difficult would it be, or how easy would it be to add support to another library for your tool? How much time would you estimate we would need, and what kind of documentation do you require? So what is the amount of documentation that we need to support a good quality LLM for this library? And what is this? Maybe you have some specific format of documentation that would be needed.
Currently, I think the community, the AI community, really likes markdowns. It's one of the best formats to parse and clean up. So if you have a markdown for your documentation, that's actually what we used for the documentation. I would suggest using markdown for the technical aspect. The more the better. Like I said, I have filters. I think one way to increase the likelihood that you're going to find the right document is restricting the search space. So I added metadata which said of this document, like for the Pharo, I have 3 documentation that's related to Pharo. For Russell, I have 1 documentation, so I don't only search within those documents. So that's 2 ways to increase it. Like I said, the more the better. But I think even if you have a little bit a little bit of documentation and you just have you just restrict it to your documentation when searching, it can have an impact, positive impact.
So 2 questions. One is first is, as I understand correctly, you parse the documents together with the questions to ChatGPT, which generates the answer. So if you have a question, how do you select the documents from the database which you transfer? So just by keywords, or how will you do that? And the second one, you mentioned that there will be internal information which is not available in ChatGPT. So in this process actually publishes everything to the ChatGPT servers actually.
Yes, indeed. Obviously, if you want to keep your data private, I think depending on how much you trust a business to not abuse your data, you might want to use a private solution or on-premise solution. So you have a lot of open source large language models. So that's one way to avoid them exploiting, when you ask questions. And then, of course, when you sign a business contract, they promise not to use your data. But to go back to your first question is, how does that work? What I kind of glossed over in the beginning is that you have another model. It's called an embedding model. You give it a text, and it'll give you an n-dimensional vector. And these n dimensions represent a sort of semantic value to your text. And so when you ask, once you've done that for all of your documents, you've generated n vector. You also, at the moment you get a question, you also send that question to the embedding model to also extract a vector. And then you just do a proximity calculation between your vectors. And so if your question is semantically close to a certain set of documents, they are more likely to pop out of be chosen. And that's how it's supposed to work.
Okay, this model also has to be trained or something. Or,
yeah.
Okay.
But you have several solutions that are open source, and you don't have to go through OpenAI. We use OpenAI because it's one of the better performing models. So I think it's a good technique is to usually start with really good, one of the best models, and to see what you're capable to do. And then if you want to go open source, and then obviously on-premise and stay away from private companies, then you can eventually fine-tune your own model and embedding model as well.
I just have a silly remark. Now I understand why I write books.
Yeah, I have a question because I usually follow all the presentations about feeding an LLM. So, and I always ask myself, so the one time you use a public source to feed that to the naive questioning. On the other side, you feed a vectorial database, but you clean the documents before. Mm-hmm. And the cleaning part is always underrepresented because saying, did you check just every of the documentation without cleaning in order to see which of the effect is the more focused input and which of the one is the cleaning, meaning reducing the background noise through the language that surrounds the terms that you're looking for.
So indeed, for this demo, we didn't actually do a lot of parsing or cleaning of information. For other application cases, we actually do remove. In our use cases, we've noticed that at least ChatGPT, since we're using GPT models so far, it's able to go through the noise of, for example, when we're parsing HTML, we also often have one thing that we have, which is hilarious for me, is that all of our documentation in HTML for one of the company we work for is Carl. They have an ASCII writing of Carl, and so it produces a lot of blocks of just garbage. And even despite that, it's able to actually give correct answers. But of course, it's better to reduce that noise.
A lot of code that we use is actually very old. So most of the documentation is actually found in mailing lists, history, and net news. Did you consider getting data from there?
Absolutely, that's definitely something you can do. Yeah, it's you just have to extract it into textual information and then parse it. It's definitely something you can do. Yeah.
I imagine that the technology behind is Python mostly.
Yeah.
Do you think that it's possible to migrate part of that to Pharo, to make the LLM about Pharo being done in Pharo instead of external technologies? Or how can you connect the stuff that we have in Pharo with these external tools? It's because I am teaching my students about AI, and I would like to have more stuff in Pharo instead of Python or other libraries. Do you
Yeah.
think that is possible, or what's the connection over there? What's the possibility?
Absolutely, it's absolutely possible. It's absolutely possible. The reason we have a tendency to choose Python, especially a library called LangChain, is that it allows us to. I turned it off. Is this library? It's a wrapper library, so it allows us to change quickly what LLM we want to use, what algorithms we want to use for our RAG technique. This is why I use Python. However, if I think personally, I think it's very basic. It's supposed to be called to an intermediary service with textual data to an LLM, and the LLM will respond with textual data. It's not very complicated to implement a post request.
Yeah, and I work in a lot of places without good connectivity. How do you think that we can get this offline, like having this? What will be the smallest infrastructure that you can take offline?
You can take it all offline. I think it's just you're going to reduce the quality of your maybe the performance of the LLMs. You have several options. I think currently, if you want to start playing with it, you have Phi, which is a Microsoft LLM. I'd have to check the permissions, especially. I mean, it's okay for students. I don't know if it's commercially viable. I have to check the license, but you can use that. It's about, they have different sizes, but I think you can need about 3 to 6 gigabytes of RAM. Obviously, it's better to have a GPU because it allows you to go faster, but it's definitely possible. Same thing for the embedding model, because you like I said, you need two models. One that will transform your questions and your documents into vectors, and one model to take a text input and then text output. And both of these models can be actually done on-premise or on your own PC, by the way.
Thank you. Sorry, we don't have time for more questions. We need to pass to the other.
Feel free to ask me questions afterwards.